Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to talk about the base-catalyzed keto-enol tautomerization. Tautomerization is just another word for isomerization, so we're going to end up with a constitutional isomer as the product. First, this reaction is promoted by both strong and weak bases and can catalyze these reactions, which means we're going to regenerate that base as the final product. The equilibrium favors the keto form, just like in the acid-catalyzed version. And again, Le Chatelier's principle is going to drive this reaction forward if the keto form is then used in a subsequent reaction. Let's look at the mechanism. Okay, so in this reaction, we're going to invoke a strong base, which is potassium hydroxide. Potassium hydroxide dissociates 100% in aqueous solvents. So here we have hydroxide as the active form of this molecule. So again, let's look at the resonance forms of this molecule to get a sense for how the reactivity might be. So we can use the lone pairs on oxygen to kick down and push the electrons onto this nucleophilic carbon. Now I say this is a nucleophilic carbon because we have an anion there in the disfavored resonance form. Remember, this is disfavored because it's zwitterionic, you have positive charges on electronegative elements such as oxygen. Hydroxide, though, can deprotonate this hydrogen that I've underlined here because it's quite basic. So in this reaction, hydroxide is going to deprotonate the hydrogen. The oxygen-hydrogen bond, those two electrons are going to form the carbon-oxygen double bond, and the current double bond becomes an anion on the same nucleophilic carbon that we saw in the resonance forms. Now this anion that you see here can then deprotonate water to reform hydroxide and make the product. The good thing is all base-catalyzed keto-enol tautomerizations have the same mechanism. You're going to have the same mechanism regardless of the base that's used here. You just have to regenerate the base because it's catalytic. I'll leave you with some questions to ask at office hour. 1, why is the keto favored? 2, how fast is this reaction? Does it depend on the strength of the base? And 3, does this occur in biological conditions? With that, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.